In this video, I will show you how you can create wall and floor structures in ArchiFrame. The process is automated in the sense that after you have defined a structural type, ArchiFrame can automatically create different kinds of 3D walls and floors that follow this type. The goal is that you don't have to manually edit any individual 3D objects in your wall. I will demo this topic through walls, but note that the same process also works for creating floor structures and even some roof structures. So let's start with a brief overview of the modeling process. There are 4 main steps involved in creating ArchiFrame walls. First of all, you need to have an Archicad model that will provide the base for your ArchiFrame model. The second step is to define the general structure of the wall in ArchiFrame. This includes things like what is the material and thickness of each layer in the wall, and for layers with studs, what is the stud spacing, and for layers with boards, what is the size of the boards, and so on. Thirdly, you need to place a wall element that has this structure and then edit the shape of the element. Later, I will explain in more detail what a wall element is. For now, just think of the element as a simplified wall whose shape and other properties are easy to customize. Finally, once you are happy with the structure, shape, and other settings of the wall element, it's time to finish the wall by creating planks. This means that ArchiFrame generates a 3D object for every individual plank, stud, and board that was included in the wall structural definition. In addition to the 3D model, ArchiFrame also generates a 2D element elevation of your wall. Now I'll go through each of these 4 steps in a bit more detail. So first of all, what kind of an Archicad model do you need to have as a base for your ArchiFrame model? Ideally, your Archicad model should be as complete as possible so that you can make the most use out of features like BIMX, the energy evaluation, and creating drawings directly from your model. At minimum, however, your model needs to contain Archicad wall and floor objects, as well as windows and doors. This is because ArchiFrame elements automatically get their geometry from these Archicad objects. Then let's move on to the second step, how to define the structure of the wall in ArchiFrame. I have here an Archicad ArchiFrame model that is missing 2 ArchiFrame walls. I will show you how to create those 2 walls from scratch. So let's look at how you can create a custom wall element type. My goal is to create an exterior wall structure that contains horizontal cladding on the outside, 2 layers of vertical battens to support that cladding, windboard, framing, more vertical battens, and gypsum board. I'll name this structure Demo Exterior 2. To create the wall element type, you first need to define some general settings, like a basic template for the element. So for example, floor and wall elements are based on different templates. You also need to define what layer the element will appear on, whether the element elevation should display the element center of gravity, and so on. The next step is to define the layers that your element contains. I will add a new layer. From this drop-down list, I could choose a pre-existing layer type, for example, a gypsum board layer. Instead, I will create a new custom structural layer by clicking the Edit/New Type button. I could create this new layer type completely from scratch, or alternatively, duplicate and edit an existing type. For the purposes of this demo, I will show you how to create a structural type from scratch. This will be the framing layer, which will look like this when it is done. To create the definition, I will first give the layer type a name, for example, framing 42 by 173 mm, spacing 600. Then I will choose the framing template for this layer. Next, I will go through the most important settings in the list below. First of all, I want to use 42 by 173 mm planks in the framing. I can choose this material from a list of predefined materials that exist in ArchiFrame. Note that it is also possible to create a new material if necessary, though I won't get into the details of that now. I could choose to set a different material for the left and right edge pieces of the framing, as well as the top and bottom plates, but in this case I will just use the same planks for these parts as well. Since all my framing therefore consists of planks that are 173 mm thick, I will set the thickness of this structural layer to 173 mm. The stud spacing will be 600 mm. This menu also has some further options, like the option to stagger the studs or to define visualization settings for 2D and 3D views. At the bottom of the menu, it is also possible to select other options, like adding a double top plate or marking grooves around each of your studs, or adding noggings in between studs. I will select the double top plate option. Now the framing layer definition is complete, so I will click OK and return to the definition of the overall wall. Next, I will create a new windboard layer next to the framing layer, this time using a windboard layer type that I have already defined earlier. I will open the settings of this layer just to give you a sense of the kinds of boarding related settings that you can influence. So as you can see, this layer type uses boarding as its template, and therefore the list of available settings is different from what we just saw when creating the framing layer. The most important settings are the layer thickness and the size of the individual boards. You can also determine various display settings and how the board should be arranged. I'll just click Cancel since I didn't make any changes to this layer type. Then I'll add the other layers to the wall's definition, with inner layers at the top and the outer layers at the bottom. I'll just use layer types that I have already created. The final step is to define the settings at the bottom of the window, which relate to the layer anchors and the relationship between different layers. Let's start with the relationship between different layers. I will first select the framing layer and set as its type main framing. Note that this layer is not following any other layer. Next, we need to define the type of the other layers and also set them to follow the main framing layer. If, for example, vertical battens or studding follow the main framing, this means that each batten will be placed right next to each stud in the framing. This makes the wall easier to construct. The same applies to boarding. If the boarding layer follows the main framing layer, then the seam between two boards will be placed in the middle of a framing stud. Finally, I will add the layer anchors. The anchor is basically just a tag for the inner or outer surface of the layer that helps you place the element in the correct position. You will soon see how this works in practice. And now my wall definition is complete, so I can click OK. Next, let's place the wall element on top of the Archicad wall in the floor plan view. The wall element structural type is Demo Exterior 2, which I just created earlier. By default, the ArchiFrame wall will have the same height as the Archicad wall. However, in this case, I want to override this setting. This is because in the Archicad model, the ground floor walls are not supporting the floor, while in the structural model, we want the second story floor to rest on top of the ground floor walls. So while the Archicad walls are 2960 mm tall, I will set the height of my ArchiFrame walls to 2600 mm. These override options ensure that the structural engineer has lots of flexibility in designing the structure, regardless of how the architect's model is put together. Now that I have set the wall height override, I will choose the gypsum board anchor and place the wall element with a line. I will place two wall elements on top of two adjacent Archicad walls. And then I will show these elements in the 3D view. So as you can see, the elements copied some of the Archicad wall's features, such as the position and size of openings. The height of the Archicad wall would also have been copied had we not created the override. This is an example of how ArchiFrame helps to reduce the amount of duplicate work in the design process. Once the architect has defined the size and position of the openings, the engineer does not have to redefine these in the engineering model. Also note that the wall elements are very simple, with each layer in the wall only consisting of one object. In other words, we have not yet created all the individual studs and boards that the finished wall will contain. This is because I still need to customize the shape of these walls a little bit, and it is easier to edit a simple wall than to adjust each of the numerous pieces in the finished wall. In this case, we need to adjust the corner between these elements and also make the exterior cladding and batten layers a little bit taller than the other layers so that the edge of the upper story floor will be covered. Let's start with the corner. In the floor plan view, I will select one of the elements, open the ArchiFrame corner tool, and apply one of these predefined corner types to the wall. ArchiFrame will then adjust the layers of each wall element so that they meet and form the corner style that I chose. Now I'll apply another predefined corner style to the second wall. Note that if the predefined corner styles do not suit your needs, then you can also define a custom corner type. Then let's change the layer offsets. I will start by opening the 3D view. Here you can see that the 4 outermost layers need to cover the floor, which is 360 millimeters tall. Then I will open the Edge Offsets window and give my offset a name. Here I will tick the boxes for the 4 outermost layers that need to be offset. And then I will input 360 millimeters for all of these, meaning that the layers will be 360 millimeters taller than the framing layer of the wall. Then I will apply the same edge offsets to the other wall. And here you can see the result. Now I am ready to create planks. I will hide some of the layers that are interfering with my view. And here you can see the cladding, battens, windboard, framing, more battens, and gypsum board. The 3D model is now in accordance with our structural type. However, at this point, I can still customize the walls if necessary. For example, maybe I would like to remove the double top plate from the wall on the right in order to make space for the windows. I could also add extra bracing to this wall by adding noggings. Therefore, even though these two walls have the same structural type, there is still some room to edit their details. And finally, here you can see how my new walls fit in with the rest of the 3D model. Lastly, note that when we created planks, ArchiFrame did not only create this 3D model, but also 2D element elevation drawings. I can find these by selecting a piece of the element in 3D and using the ArchiFrame navigation tool to open the relevant elevation drawing. This drawing contains a cut list showing each piece of the element and also shows projections of the element from different angles. I will now end the video with a quick recap. So I have shown you how ArchiFrame allows you to automate the modeling of wall, floor, and some roof structures. In this process, you first need to have an Archicad model. Then you need to define the ArchiFrame structure. Now you can create wall elements that use this structure, and you can edit the shape of those elements. Then you can create planks to finish the 3D model and create element elevation drawings. At this point, you can still customize the structure of the walls if necessary. With this kind of design automation, you can not only work faster, but also avoid mistakes that happen as a result of manual 3D model editing.